Writing software used to require a team of engineers typing out syntax over several months. Today, you type a plain English request into an interface, and the digital building blocks start assembling themselves. In early 2025, AI researcher Andrei Karpathy coined a term for this: vibe coding. It refers to a style of development where a user provides a general description of what they want and trusts an AI assistant to handle the heavy lifting. The workflow shifts from writing code line by line to managing high-level intention. The AI handles specific implementation, identifies software bugs, and deploys to the cloud. For operations managers, this means a functional prototype that once took months to build in a traditional dev cycle can now be ready for internal testing in a few hours using tools like Bolt.new or Google AI Studio. Vibe coding moves the power to create software from specialized engineering departments to the employees managing the daily work. It effectively removes the months of wait time between identifying a business need and launching a tool to solve it. While individual users can move fast, large enterprises are anchored by massive aging core software systems. These massive legacy platforms handle all the mission-critical data that keeps the entire world's global logistics and finance running smoothly. For companies like FedEx and Cisco Systems, the traditional strategy of tearing out and replacing these systems is no longer the default. They are choosing to keep their legacy cores in place. This creates a dilemma for chief technology officers. They must decide between a multi-year foundational system overhaul or a strategy that leaves the core intact while using AI to build small, specialized applications around the edges. To make this choice, tech leaders evaluate 4 specific factors: speed to deployment, the level of risk, licensing costs, and the total burden on their engineering staff. This decision dictates whether a company commits years of capital to infrastructure or relies on a fast, decentralized ecosystem of AI-generated tools. Historically, rip and replace was the gold standard for modernization. It involved decommissioning old systems to move an entire organization onto a single, unified data architecture. These projects are notoriously expensive. Migrating millions of records and retraining thousands of employees across a global footprint often requires a 3 to 5 year roadmap and a 9-figure budget. Security and regulatory hurdles add more friction. Every line of code in a core system replacement must undergo rigorous compliance checks, which frequently stall the transition for months or years. While a unified system is the theoretical goal, the practical cost is a loss of business momentum. Companies often find themselves frozen in place, unable to innovate while they continually struggle to complete the migration. For large, risk-averse organizations, the possibility of a total system failure during a swap makes rip and replace an unacceptable gamble. Instead of replacing the core, companies are adopting the micro-app overlay strategy. They use AI native editors like Cursor or Replit to build specialized tools that interact with the existing architecture. The legacy core remains a secure, stationary gray block. When teams need to automate unsupported workflows, they vibe code microapps that snap onto the perimeter. This lowers OpEx. Companies stop paying licensing fees for massive enterprise suites by building internal alternatives for simple tasks. This approach allows teams to launch new internal solutions every week at a fraction of the cost of traditional development. The trade-off, however, is a fragmented ecosystem where dozens of small apps must be managed individually. Vibe coding can create the illusion of a finished product. An AI can generate a polished interface in minutes, but the camera move reveals what's really there: a thin wireframe scaffolding that lacks the depth of professional engineering. This is the scaffolding reality. AI code is fast, but it often lacks the built-in security protocols and the scalability required to handle thousands of concurrent users without breaking. Deploying a microapp directly to a mission-critical or customer-facing department without human review introduces significant business risk. Furthermore, the maintenance doesn't disappear. When an API changes or a bug surfaces in one of these fragmented apps, the internal engineering team is responsible for the fix. Vibe coding hasn't replaced the need for developers. Instead, it requires experienced engineers to step in as humans in the loop, turning fragile AI scaffolding into reliable enterprise assets. To balance speed and safety, managers need a framework to decide when to build a micro app and when to invest in the core. The process begins by identifying the software gap. If it involves mission-critical data, The flowchart branches left. These projects require traditional development and high-security core upgrades. But if the gap is a niche internal workflow, it branches right to a highly efficient, vibe-coded micro app. Using this logic prevents non-technical teams from accidentally touching the company's most sensitive data, while still giving them the freedom to innovate. For CTOs, vibe coding is a tool for rapid experimentation and cost reduction around the business edges, not a replacement for a secure data foundation. Operations managers can now solve their own workflow bottlenecks using AI, provided they keep these tools away from customer-facing systems. Software engineers are shifting their focus away from manual syntax. They are becoming architects and auditors, ensuring that the high-speed output from AI models is secure and fits the company's broader system. Companies that maintain a stable legacy core while using AI to build agile tools at the edges avoid the paralysis of a full system overhaul. They remain operational and adaptable, while their competitors are still caught in years of data migration.